This is a candy bar in its wrapper. Many food products like this one use a cold sealing adhesive to seal the wrapper. Cold sealing adhesives can bond without heat, which ensures the candy doesn't melt during the packaging process. During production, the adhesive is applied to specific areas on the inside of the wrapper so the candy bar can be packaged and sold. But this batch of wrappers is showing signs of failure, and we want to know why. FTIR microscopy is the ideal technique to determine the root cause of defects. We'll be showing you how that's done on the Lumos 2 FTIR microscope. To start investigating the wrapper, it's placed on the sample stage of the Lumos 2. Right away, we can visually see some rips and tears in the adhesive layer. But to get a deeper understanding of why this batch of wrappers is failing, we can use microchemical FTIR analysis. All we need to do is select a region of interest to be analyzed. We can adjust the spatial resolution and number of points in that region of interest, and then click to start the analysis. And that's it. The motorized germanium ATR crystal automatically starts scanning the sample point by point. Once the data is collected, a chemical map of the adhesive can be created manually by selecting the spectral features that are unique to the adhesive. Or this can be done automatically using Bruker's adaptive chemical imaging feature. This smart algorithm groups IR data according to spectral variances to create a chemical image. In this case, the algorithm found an unknown contaminant, which can be easily identified using a spectral library search. It turns out this contaminant, which was the culprit for the failed adhesive application, is cellulose residue. This could have come from a variety of sources, such as clothing, cleaning rags, or tissue paper. As you can see, the Lumos 2 FTIR microscope is a straightforward and powerful tool for failure analysis. Thanks for watching. We'll see you next time.